In this question, we have to find out the coefficient of x to the power 5 in the expansion of the product of two binomial expression. So let us begin by assuming that our x to the power 5 occurs in the r plus 1th term for the first binomial expression, which is 1 plus twice x raised to the power of 6, and it occurs in the n plus 1th term of 1 minus of x raised to the power of 7. Raised to the power of 7. Now we try to find out the value of t r plus 1, and that will be equals to 6 c r times the first term, which is 1, times the second term, which is twice x raised to the power of r. This will be equals to 6 c r times 2 raised to the power of r times x raised to the power of r. Then we find out the value of t n plus 1, which will be equals to 7cr times the first term, which is 1, times the second term, which is negative x raised to the power of negative x raised to the power of r, and this will give us 7cr times negative 1 raised to the power r times x raised to the power r. Now this is our equation number 1, and this is equation number 2. Now in equation number 1, let us assume that the value of r is equals to 5. Since we have to find out the value of x raised to the power of 5, so we are assuming r is equals to 5. So that gives us t 5 plus 1, which is 6, is equals to 6c5 times 2 raised to the power of 5 times x raised to the power of 5, and this value is equals to 6 times 2 raised to the power 5, so is 32, times x raised to the power of 5. So we'll multiply 6 and 32, and that would gives us 192 x raised to the power of 5. Then we go to equation number 2, and here also we let go the value of n equals to 5, and that should give us t 6 is equals to 7c5 times negative 1 raised to the power 5 times x raised to the power of 5, which is equals to negative 7c5. Then we can use a calculator to find the value of 7c5, and that would give us negative 21 x raised to the power of 5. Now that we have the coefficient of x to the power 5 in both the two binomial expressions, so the final coefficient will be the coefficient of x raised to the power of 5 in the product, or you can say in the expression 1 plus 2x raised to the power 6 times 1 minus x raised to the power of 7 will be simply equals to the sum of the coefficient of x to the power 5 in both the two expression. So that is 192 plus minus of 21, and that gives us 171. Let's go to the next question. In this particular question, we have to find the coefficient of x raised to the power of n in the product of the given binomial expressions. So we begin by first multiplying the first binomial expression to the second one, and that should give us 1 times 1 minus x, so that will give us 1 minus of x raised to the power of n plus x times 1 minus of x raised to the power of n. So this will be our equation number 1. Now what we do, we'll try to find out the r plus 1th term of 1 minus x raised to the power of n. The r plus 1th term of 1 minus x raised to the power of n will be t r plus 1 equals to ncr times 1 raised to the power of n minus r, which is always 1, times negative x raised to the power of r. And that value will be equals to ncr times negative 1 raised to the power of r times x raised to the power of r. Now we substitute this value into a first equation, so that would give us, so equation 1 will now give us, writing the r terms, ncr negative 1 raised to the power of r times x raised to the power of r plus x times ncr times negative 1 raised to the power of r times x raised to the power of r. This will be equals to ncr times negative 1 raised to the power of r times x raised to the power of r plus ncr times negative 1 raised to the power of r times x raised to the power of r plus 1. So we have added the coefficient, or we have added the index of x. Now let this be equation number 2. Now in the first term, so we look at the first term, and here we replace r by n, and that gives us ncn times negative 1 raised to the power n times x raised to the power of n, so that we get the coefficient of x raised to the power of n. Then in the second term, we replace r by n minus 1, and that should give us ncn minus 1 times negative 1 raised to the power of r, n minus 1, which is the value of r, times x raised to the power of n minus 1 plus 1, so that would give us simply x to the power n. So now that we have the coefficient of x to the power of n, so in the given expression, the final coefficient will be the final coefficient value should be so coefficient of x to the power of n will be equals to ncn times negative 1 raised to the power n plus ncn minus 1 times negative 1 raised to the power of n minus 1. So this is the final value. We'll now try to further simplify this, and that should give ncn is always positive 1, so we have simply negative 1 raised to the power of n plus, now ncn minus 1 can be rewritten as n factorial over n minus 1 factorial times n minus of n minus 1 factorial. So that will give us negative 1 raised to the power of n plus n factorial can be written as n times n minus 1 factorial divided by n minus 1 factorial times 1 factorial. So we can factor out n minus 1 factorial from both the numerator and the denominator. Or we also have negative 1 raised to the power of n minus of 1. So this would finally give us negative 1 raised to the power of n plus, we have left out the negative 1 raised to the power of n minus 1, which can be written as negative 1 raised to the power of n times negative 1 raised to the power of negative 1. Now, we know that the negative 1 raised to the power of negative 1 will give us a negative 1. So we have negative 1 raised to the power of n times n. So we take the negative 1 raised to the power of n common and we get finally 1 minus n. So this is the final answer. So in this particular question, we are given that the coefficient of x and x squared in the expansion of the product of these two binomial expressions are 3 and negative 6. We have to find out the value of m. So we begin by finding out the r plus 1th term for the first binomial expression, which is 1 plus x raised to the power of m. And then we find out the p plus 1th term for the second binomial expression, which is 1 minus of x times raised to the power of n. So what that would give us t r plus 1 is equals to mcr times 1 raised to the power of m minus r times x raised to the power of r, which will be mcr times x raised to the power of r. For the second one, the p plus 1th term, so tp plus 1 is going to be equals to ncp times 1 raised to the power of n minus p times negative x raised to the power of p, which would give us ncp. So 1 raised to the power of n minus p is going to be 1. We pull out the negative number, so we have negative 1 raised to the power p times x raised to the power p. Now we take the product, both of them, that should give us tr plus 1 times t p plus 1 is equals to mcr times ncp times negative 1 raised to the power of p times x raised to the power of r plus p. So let this be equation number 1. Now, in order to find out the coefficient of x first, so we're gonna have two possibilities. Possibility 1 is going to be, let's call it possibility A. The value of r could be equals to 0 and p could be equals to 1. So that the product becomes mc0 times nc1 times negative 1 raised to the power 1 times x raised to the power of 0 plus 1. Then we expand the values. mc0 is going to be 1, nc1 is going to give us n, negative 1 give to the power of 1 is simply negative, times x. So this is the first coefficient of x. Then we have possibility B, where r could be equals to 1 and p will be equals to 0. So that should give us mc1 times nc0 times negative 1 raised to the power of 0 times x raised to the power of 1 plus 0, which gives us mc1 is going to be m times nc0 is 1, negative 1 raised to the power of 0 is 1 times x. Now we add the two coefficients together. That would give us the coefficient of x. So the coefficient of x will be equals to, we add this coefficient, so that will be negative n plus m. And according to question, this is equals to positive 3. So let this be equation number 2. Now we move on to the next possibility. So we'll consider equation number 1. We go back to that. Now we have to find out the coefficient of x squared. So now we'll have 3 possibilities. Possibility number A, the value of r could be equals to 0 while p is equals to 2. So that would mean we have mc0 times nc2 times negative 1 raised to the power 2 times x raised to the power of 0 plus 2. So that would give us mc0 is 1, nc2 will be n times n minus 1 divided by 2 times positive 1 times x squared. So this is the first possibility. The second possibility is r could be equals to 2 and p could be equals to 0, which would give us mc2 times nc0 times negative 1 raised to the power 0 times x raised to the power of 2 plus 0. So this is equals to mc2. When we expand it, we get m times m minus 1 divided by 2 times nc0 is 1, negative 1 raised to the power of 0 is 1 times x squared. And the final possibility could be r is equals to 1 and so is p. And that should give us mc1 times nc1 times negative 1 raised to the power of 1 times x raised to the power of 1 plus 1, which will be equals to mc1 will be m times nc1 will be n, negative 1 raised to the power will give us a negative 1 times x squared. So to find out the coefficient of x squared, we get the coefficient of x squared be the sum of the 3, which will be n times n minus 1 over 2 plus m times m minus 1 over 2 minus m times n, the whole thing. So this is going to be the coefficient of x squared, and this value is equals to negative 6. Now we further simplify it. To get n times n minus 1. So what we're going to do, we're going to multiply throughout by 2 plus m times m minus 1 minus twice of mn equals to negative 12. So this will be our third equation. Now we'll take the second equation, and we got negative n plus m equals to 3. So from here we can write that m was equals to 3 plus n. Now we're going to substitute the m by 3 plus n into equation number 3 such that we get n times our equation 3 would now give us n times n minus 1 plus m will be 3 plus n times 3 plus n minus 1 minus 2 times 3 plus n times n equals to negative 12. So n times n will be n squared minus n plus 3 plus n times 2 plus n minus 2 times 3 is 6 plus twice of n whole times n is equals to negative 12. And n squared minus n plus, we distribute 3 plus n to it, 2 plus n. So that should give us 3 times 2 is 6, plus 3 times n is twice of n, plus n times 2 is twice of n, plus n, n times n is n squared minus 6n minus 2n squared, which is equals to negative 12. Now you can see that n squared plus n squared minus negative n 2n squared will cancel out. Then let's write it down. N squared plus n squared minus 2n squared. They're going to cancel out each other. Then we're going to combine thrice of n plus twice of n. So this will give us thrice of n plus twice of n minus of n minus of 6 of n equals to negative 12. And we're taking the positive 6 to the right hand side. So that gives us negative 6. Then we're finally left with this term, the first three terms, add up to 0. Then we have 3n plus 2n, which is 5n. 5n minus n is 4n. And 4n minus 6n gives us twice of n, which is equals to negative 18. So that gives us twice of n is equals to 18. N is equals to 9. Now that we have the value of n, so we go back to equation number 2, where m is equals to 3 plus n. We substitute the value of n, which is 9, and that would give us m value to be equals to 12. In this particular question, we have to find the coefficient of x in the expansion of the product of the two binomial expression. So we begin by finding out the r plus 1h term in the binomial expression, 1 plus 1 over x raised to the power of it, and that should give us 8cr times 1 raised to the power 8 minus r times 1 over x raised to the power of r. This is our r, which will be equals to 8cr times 1 over x raised to the power of r. Now what we do is we're going to replace 1 plus 1 over x to the power of 8 by the general term. So that should give us 1 minus twice of x cubed plus 3x raised to the power of 5 times 8cr times 1 over x raised to the power r. Now we're going to take the product. So 1 times 8cr is going to be 8cr times 1 over x raised to the power of r minus 2 times 8cr times x cubed over x raised to the power of r plus 3 times 8cr times x raised to the power 5 divided by x raised to the power of r, which will be equals to 8cr times x raised to the power negative r minus 2 times 8cr times x raised to the power 3 minus r plus 3 times 8cr times x raised to the power 5 minus r. Now that we have the general term, we have to find out the coefficient of x. Now we're going to assume different values of r. Now we can see that for any value of r, the first term will never give x to the power of 1. And r cannot be negative, so we cannot take r equals to negative 1. So the first term will not contribute to x. Now we move on to the second term, which is negative 2 8cr times x raised to the power of 3 minus r. Now what we do, so we substitute r by, let r is equals to 2 and substitute into the second term. So that should give us a negative 2. The second term, so I'm writing here the second term, will be equals to negative 2 8c2 times x raised to the power of 3 minus 2, which is equals to negative 2 times 8c2x. So now we have x here, so the coefficient of x will be simply equals to negative 2 times 8c2, which is equals to negative 2 times 28, which is equals to negative 56. So this is the coefficient of x. Now we go to the third term, and then we're going to substitute. Then let r be equals to 4, and then we're going to substitute, so that our third term becomes 3 times 8c4 times x raised to the power of 5 minus 4. So this gives us 3 times 8c4 times x. Therefore the coefficient of x will be simply equals to 3 times 8c4, which is equals to 3 times 70, which is equals to 210. Now that we have two coefficients of x, so the final coefficient, therefore we can write coefficient of x in the product of the given binomial expression will be simply equals to the sum of the two coefficients, which is negative 56 added to 210, and that gives 154. So this is